So we're going to look at how to solve equations with variables on both sides. You'll notice that these steps should be kind of repetitive by now. You're always going to start by cutting your equation in half. You're going to get rid of one of the variables. So this time I have like x's on both sides of my equation. I need to get rid of one of those, and I'm going to do that by either adding or subtracting one of the variables, because I need to isolate it first. So first I have to put them all on one side. And then I'm going to use the opposite or the inverse operation to do that. So if the variable is being added, I'm going to do the opposite, which is subtract it in order to get rid of one of the variables, or if it's being added or if it's being subtracted, I'm going to add it. Okay, after I use the inverse operation in order to move one of the variables, then I have to isolate that variable. Okay, and this is the same step you've used over and over again when solving equations. You're always using the inverse operation or the opposite to do this, and again, you can always check your solution. So really all we've done is add the second step in here. And let's look at this first example. 3x minus 9 equals 6x. So we've solved equations but we're equal to 6, all right, but this time we have an x on both sides of the equal sign. So this is how this is a little different. All right, so again, we're going to be cutting this in half, right? I can see, right, that 3x minus 9 equals 6x. I want to get rid of this 3x, put it over here with the 6x. So I have to do, this is a positive 3x right now. So to get rid of it, I need to subtract 3x, or I need a negative 3x. So I'm going to subtract. 6x minus 3x is just a positive 3x. I treat this the same way even if there's a variable. So 6 minus 3 is 3x. And I'm going to bring down the minus 9. Okay, and then now I need to get rid of the 3 that's with the x. So I'm going to divide by 3. These go away. X is just equal to negative 3. Again, you can always check your answer by putting it back into your equation. So this time, because x is in two places, then it's going to be 3 times negative 3 minus 9 equal to 6 times negative 3. I have to plug it in both places that I see in x. And then don't forget to use PEMDAS when you're solving. So I need to move my multiplication first. 3 times negative 3 is negative 9. 6 times negative 3 is negative 18. Then this is subtraction, so I can rewrite this as negative 9 plus, okay, keep, change, negative 9, so that's negative 18. Equals negative 18, so that is the correct answer. All right? Sorry, guess you couldn't see what I was doing. But yeah, so negative 9 plus a negative 9, if I go ahead and rewrite that, negative 9 plus negative 9, then I get negative 18 here. Okay? All right, so let's look at a few examples. 7a minus 5 equals 2a minus 15. I'm going to start by cutting it in half. And since I have two a's, I need to move one of them. I always move the smaller one. That way I can work with a positive number. So since I have a 7a here and a 2a here, this one's smaller, so I'm going to move it. I need to get rid of it, so I'm going to do the opposite. This is a positive 2a, so I'm going to subtract 2a from both sides. Over here, these go away, and this minus stays with the 15, so this is still negative 15. 7a minus 2a is 5a. Then I bring down the minus 5 because I haven't done anything to that yet. Okay, I'm going to cut it in half again and just solve this like a regular problem. I always want to get rid of adding and subtracting first. So the opposite of subtracting 5, adding 5, because now I have 1a, so this is the one I'm going to try to get by itself. Add 5 on this side. All right, so these go away. This side is just 5a. Negative 15 plus 5, these are different, so I'm going to subtract them and then keep the sign of the largest, which would be negative 10. So 5a equals negative 10, and then I'm going to go ahead and divide it in half again. This is times 5, so I'm going to do the opposite, which is divide by 5. So negative 10 divided by 5 is negative 2. Again, I can check this if I want by plugging it back in. All right, that would be 7 times negative 2 minus 5, and then on this side, it's 2 times negative 2 minus 15, the same thing. All right, 7 times negative 2 is negative 14 minus 5. Over here, 2 times negative 2 is negative 4 minus 15. Okay, I can rewrite this. Negative 14, keep that, plus, change this to negative 5. Over here, keep the negative 4, change to plus, change to the opposite, negative 15. This is negative 19. This is negative 19. So yes, negative 2 is a solution to this equation. Okay? All right, if I look at number 2, it works the same way when you have decimals. You cut the number or cut the equation in half. I need to have a D on this side and a D on this side. I need to move one of them. All right, so I'm going to move this one over here. Since that's all that's on this side, that will make the side stay simpler. So I'm going to go ahead and do the opposite of adding 2.5, which is subtracting 2.5. I'm going to line up my decimal. So these go away. The side still has the 8. 3.5 minus 2.5 is 1.0D. Well, 1.0 is really just 1D or just D, right? Which is actually what I'm solving for. So D equals 8. Again, I can solve this by plugging in D here and D here. Okay? All right, number 3. 5p plus 2 equals 4p minus 1. So I'm going to cut it in half. I'm going to move one of my variables. So again, I like to move the one that's smaller. So since 4 is smaller than 5, I'm going to do the opposite, which is subtracting 4p, subtracting 4p. So these go away. On this side, I still have the minus 1. Over here, 5p minus 4p is 1p, which is the same thing as just 2, or I'm sorry, is just p plus 2. All right, so now I'm going to get the p by itself. I'm going to do that by doing the opposite of adding 2, which is subtracting 2. All right, those go away. The side is p. A negative 1 plus a negative 2 is negative 3. And so my answer is negative 3. Again, if you want to check your answer, plug back into your equation and see if both sides come out the same. We can try it again. 5 times negative 3 plus 2, and 4 times negative 3 minus 1. See if both sides come out equal. 5 times negative 3 is negative 15 plus 2. Over here, 4 times negative 3 is negative 12 minus 1. Negative 15 plus 2. They have different signs, so I subtract. I keep the largest sign, negative 13. Negative 12 minus 1, I'm going to keep. Change to add, change to the opposite, and then add these because they're the same. So I can see negative 13 equals negative 13, so negative 3 is the solution. All right, on 4, now 4 is a little different because I do have a z on both sides of my equation. I have 2 z's on this side, and I have this parentheses here. So I need to simplify this as much as possible before I try to move anything. I'm going to use the distributive property on this in order to simplify it. So remember, anytime you have a number outside parentheses, that's multiplication. And when there's more than one thing inside your parentheses, you have to multiply that 3 or that number outside the parentheses times everything inside your parentheses. So I'm going to start there. So this side is still 8z minus 22. 3 times 3 is 9z. 3 times 11 is 33. Then minus z. And when a variable it does not have a number, you can think of it as just a 1z. So again, I can simplify this side over here. Since these both have a z, and these are considered like terms, 9z minus 1z is 8z. So now I have 8z minus 22 equal to 8z plus 33. All right, so I want to cut this in half, and I want to get rid of one of my variables. Now, since these are the same, it doesn't really matter which one I move. So if I do the opposite here and subtract 8z, what I end up with is 0z on both sides. Well, 0z is just 0. So really all that's left is negative 20 on this side and 33 on this side, and I have no variable. So what that tells me, okay, is this is not true, all right? And so there is no solution to this, basically. So when you end up with something, if your variables cancel out and you get something that's not equal to each other, then you really have no solution to this. There is no solution for z that would make this equation true, okay? All right, so let's look at the back of this. You use the same rules when you're using decimals and fractions. Just be careful with this. So I'm going to cut it in half. I'm going to isolate the x, right? So since 9 is less than 12, that's the one I'm going to move, minus 9.9. I'm going to line up my decimal. So over here, 12.9 minus 9.9 is going to be 3.0x plus 10 equal to, these go away, this is 34. 3.0x is really 3x plus 10 equal to 34. All right, this is a regular equation. Cut it in half. Get rid of adding and subtracting. First, so I'm going to subtract the 10. These go away. So this side is 3x. 34 minus 10 is 24. And then go ahead and solve it again. I'm going to get rid of multiplying by dividing. X equals 8. Okay. All right, and then the last one, I'm working with fractions over here. So there are a couple ways to do this one. Since these all have fractions, I'm going to change my denominators so that they're all the same at the beginning. That way I'm not having to worry about it later. So I'm going to find the common denominator of all of these, 4, 2, 4, and 8. So the multiples of 8 are 8 and 16. I know that the multiples of 4 are 4 and then 8. Multiples of 2 are 2, 4, 6, 8. So since I can change all of these to 8, I'm going to do that. So if I want to change 4 into 8, I have to multiply it by 2. So I need to do that to the top as well. So negative 5 times 2 is negative 10 over 8c. Over here, if I want to change the 2 into 8, I have to multiply by 4. So minus 1 times 4 is 4 over 8 here. And then I have a negative 3/4, so I need to multiply that one by 2. It gives me a negative 6 over 8. And then this one's already 8, so I don't have to change it. All right, so all I did was find the common denominator of all of these. Now I'm going to isolate my variable. So since the 5/8 is positive and the negative 10/8 is negative, I'm always going to try to move the smaller one to the bigger one. So I'm going to do the opposite here since negative is smaller than positive, and subtracting or adding a positive 10/8c to both sides. Okay, we'll make this go away. So this side is negative 4/8. This is negative 6/8. And then 5 plus 10 is going to give me 15/8c. All right, and I'm going to keep solving. I need to get rid of the negative 6/8. So I'm going to do the opposite, which is adding a positive 6/8. Okay, so these go away. This side is 15/8c. Negative 4 plus 6 is a positive 2/8. Keep the denominator. All right, and then the last thing I have to do is get rid of this fraction. This fraction is being multiplied by c. So the opposite of multiplying is dividing. So I need to divide by 15/8. So over here, I'm dividing by 15/8. All right, so on this side, I just get c. Here, I'm going to rewrite this as 2/8 divided by 15/8. And I need to keep, change, flip. Keep, change, flip. So they keep the 2/8, change to multiply, and flip this to 8 over 15. Okay? All right, so this is another place where it's maybe simpler to simplify before you multiply. The 2 and the 15 don't simplify, but 8 and 8 are both divisible by 8. All right, so then if I go ahead and multiply top times the top, I get 2. Bottom times the bottom, I get 15. So c is equal to 2/15. Okay? So again, on this one, it took a little longer. You're going to notice that these equations take longer to solve because there are more steps to solve them. Okay, but with fractions, I changed everything to a common denominator first and then tried solving it. But the steps after I had a common denominator were all the same. Isolate your variable by using inverse operations. Okay, see you soon.